Hey everyone, I'm Ryland and I lead the product effort among a few other things here at Temporal. I've been at the company around 9 to 10 months, so I've had a decent amount of time to really, get my footing and kind of see what the problems and the challenges that we're struggling with and what are the major things that we need to improve on. And one of the biggest areas that I've noticed needs improvement is that there's not enough practical content about Temporal, about workflows, about all the aspects of the system, and just generally how to succeed with the technology. And so long term, our plan is that we want to have high quality content for all of these things. We want to have videos, we want to have tutorials, we want to have blog posts, we want to have reference applications. But the reality is that we're a company of less than 20 people, and it's going to take a lot of time and energy and resources before we can actually get to a place where we have all that stuff. And so right now, we just need something. And my hope is that this will be the first video in a series that will be that something, or at least part of that something, because I think in the short term there's a lot of good that we can do to get people successful with the technology before we have this huge machine that can produce high quality content. And one of the biggest observations that I've had that kind of drives this motivation is that the bottleneck for producing temporal content isn't like having things to produce content on. The bottleneck is that there aren't enough people who are even qualified to make content. And considering I'm one of the few people that actually is qualified to make this content, it just feels like it makes common sense that I start doing it. And so the caveat here is that it's definitely not going to be a well-structured series. I'm going to either cover topics that I enjoy or ones that I feel like a lot of people have been asking for. There's a lot of demand for. There may not be a lot of rhyme and reason for the ordering of the videos. I might not do things linearly. And also videos are going to be very low polish. They're going to be optimized for like conveying a concept and, being very concise at doing that, and not necessarily for, being expository and, well edited. And there's definitely not a script, so you're going to be struggling with me at times. There's going to be some parts where, I like doing things in one take, so you get what comes with that territory. And so the last thing is that some of the videos may be aimed at entry-level users, and some will be much more advanced. This is a video that's definitely aimed at the more entry-level users, and I'll try to do my best to call it out before the start of a video so you know what you're getting into. And so as I said, I want to start this first video off with like baby steps. So we're going to be covering the very, very basics of writing workflows in Temporal, and kind of the associated concepts that you need to be familiar with to do that. All right. So let's get started. Before we can even start writing or even talking about this small application that we want to build with Temporal, it's probably pretty important that we actually have Temporal running locally. So I'm going to go ahead and jump over to this other terminal window. Start Docker Compose, using the Docker Compose repo, which is available on our GitHub. And I'm using the -d flag just because I'm not a fan of the spam to my console, but it's definitely a personal preference. So we're back now in the project directory. We're going to start by doing a go mod init. We can do this because we know that immediately we need to install the Temporal SDK. The Temporal SDK is a dependency for any Go-based development you want to do with Temporal. So it just makes sense to get that out of the way. And so now we have the project scaffolding set up and Temporal is running locally. We should start talking about this simple workflow that we want to write today. And so I'm going to be following along with the hello example, which is available on the Go samples repo in our GitHub. I chose this sample because it's the first video. I kind of want to start off, take a small bite. But also I want to make sure that the focus of the video is much more about how the pieces of Temporal fit together rather than just being like a generic tutorial about how to write code. And so now that we understand the scope of what we're going to be trying to write today, let's talk a bit about how you actually approach development with Temporal. So when you're writing Temporal applications, there's traditionally three different components, major components that you need to be aware of. The first one is the workflow. So this is your actual logic. So, if you're writing like a business facing application, this is where the business logic goes. And so, you'll be spending most of your time writing workflow code and activity code, but it's not the only major component of Temporal. And so the second component of Temporal is what we call a worker. So a worker is a bit of a unique concept in Temporal, but you can think of it as a process which actually hosts your workflow and activity code. And so if you're coming from a traditional microservices background and you have like a Node.js application server, the worker is somewhat equivalent to the actual server itself. And so if your business application starts getting a lot more load and you have a lot more users, usually you have to scale your workers out in addition to the Temporal cluster. So that's a worker. The third component of building temporal applications, and this one isn't strictly speaking necessary, but it's very convenient, is what we call a starter. And a starter is essentially just a small program that's used to kickstart or kind of kick off your workflow. And it saves you a lot of time during the development phase, especially. Theoretically, you can do this either via RCLI or even just directly over gRPC. But most of the time, you don't want to be doing that, trust me. So it just makes sense to have a starter in most cases. So we're going to go ahead and just create 3 directories. So we're going to create one for the workflow, one for the worker, and one for the starter. So we're going to go ahead and do that now. We're going to start by defining our workflow code. And I'll tell you in general, we're going to be doing things a bit differently compared to how, for example, I would traditionally write an application with Temporal myself, just to make sure that things are kind of approachable and clear from the beginning. So it's go. We have to start by defining a package. We're going to go ahead and do that. So now we're actually in the part where we're going to write some workflow code. In Temporal, workflows and activities are both just special purpose functions. And you can call them whatever you would like. You have to remember that name, you'll use it later, but there's no sort of enforcement that we put there. So we're going to go ahead and call it workflow because we're maybe not the most creative. And the first thing is that workflows do require one parameter always, which is the workflow context. So we're going to go ahead and say workflow.context. And this is a hello world example. And so we want to take in a string. So we're going to go ahead and do that now too. Now, the thing is that workflows also have a required return argument, which is an error. But we also, again, this is a hello world example, so we're going to want to return a string. So we're going to do a string and an error. Now, it's going to complain for 2 reasons. First, I need to return something because I have 2 return arguments. So go ahead and do that. Now, the second thing it's complaining about is that I've used something and I haven't imported. So we're going to say go.temporal.io. This is that package that we installed earlier, /SDK/workflow. Awesome. Okay, so now we have the workflow written. We're actually not going to do any more with it right now just because we want to keep things simple. But we will go ahead and write the kind of shell of our activity the same way we did with our workflow. So we'll go ahead and say context. Now the one difference here is that we're using, it's a required parameter for activities, but it's the built-in Go context, not the workflow context that comes from Temporal SDK. And then once again, hello world, so we're going to take in a string. Activities are also required to return an error, so we're going to go ahead and do that and then add that additional string parameter that we're interested in. Return some stuff, so go is happy. Now we will need to import one more thing. Actually, this is not a temporal package, this is just the Go context. Awesome. So this is our very, very, very minimal workflow implementation. We'll definitely improve it from here. But before we do that, maybe let's go and actually start writing our worker. So I'm going to go and put main.go file in the worker. Now, the thing about a worker, which is a bit different than a workflow, is that we do have to directly run the worker. Like we have to run it as a Go process. So what that means is that we need to give it a package main, because that's how it works in Go. And then we can go down here and we can start defining our main function. And again, a worker's point, its purpose is that it's going to host your workflow code. So the first thing you always have to do is instantiate a temporal client. This is like, if you've ever used any sort of like database like Redis or even, Postgres or anything like that, you need to have some sort of local Postgres client. So it's kind of a good analogy to how the temporal client works. The one thing being that, there's no sort of connection pooling or anything like that in Temporal. So you don't have to worry about like dropped connections in that sense as you would with a traditional client-side library for a database. This can fail because it is indeed a remote operation. So we're going to go ahead and just handle that case. We're just going to say, like log.fatal, unable to make client. We're going to give it an error. Nice. Now it's going to immediately complain, as it should, because we need to import some stuff that we haven't. So I'm going to go ahead and do that now. So one is, again, the Temporal SDK itself. We need to get the client. So we're going to do that. And then also there's this built-in Go logger that we haven't included either. So let's get that out of the way as well. Nice. Okay, so it's still complaining mostly because we haven't actually used this stuff and maybe I used the wrong version of, no, it's just wrong. So now we can actually, the other thing we need to do is, while there's no like connection pooling, it is a resource. So you want to make sure that it's going to be closed after it's done being used. So we're just going to go ahead and defer that until the main function finishes. And so now we have the client instantiated. This is something that you need for a worker, but it's not even really worker specific. So now we actually have to create our worker. So we're going to go ahead and do w equals worker.new. And this is a call available from the temporal worker package, which I'll implement in a sec. We're going to pass it the client. Now we're passing it a task queue. A task queue is a routing mechanism and like a load balancing mechanism in Temporal. And so we won't really get into it too much this time, but you need to make sure that you remember what you put here if you change from what I did. And so The next thing we have to do is register our workflow and activity implementations with the worker. So we're going to go ahead and do that. And now it doesn't really make much sense for us to do this until we actually have those imported. So before I do anything, I'm going to first import the worker that we, SDK, worker that we didn't before. And now I'm also going to have to import whatever the name of this package is, which I think is Ryland G. See, this is where it always gets me. So let's just go ahead and look at our Go mod. Ryland G hello temporal. All right, awesome. And then this is, I created a separate package, so it's going to be in the hello workflow package. There we go, nice. Cool. Okay, so now we have our worker dependency imported, and we actually have our code imported, so we can go ahead and actually register this workflow. This makes it so the worker that we created can actually process this if it's sent. Or if it's pulled more so. And so we're going to register the activity as well. Hello workflow.activity. Awesome. Cool. So the last thing that we have to do, we have created a worker. We've basically registered the workflows and activities that we want it to be able to handle. The last thing that we're responsible for now is actually running the worker. So we're going to go ahead and do that. Yeah, worker error equals w.run. And this one is a bit hard to explain, but essentially this is just a way for us to be able to control C from the worker when we run it. So we're just going to go ahead and let it do that. All right, so now what we need to do is once again log, just to make sure that if something goes wrong here, we know about it. And we'll just say, oops, unable to start workflow. Awesome. So this is basically the entirety of the worker. They tend to be very straightforward. You'll end up writing quite a few of them because they're always required, but you know, there's not a lot of complexity there in most cases. Awesome. So now what we want to do is actually go and write our starter. The rationale here is that once we have our starter written, then we can actually go and test this. And as of right now, you know, it's something that's very theoretical. So I'm going to go ahead and create in the starter directory another main.go, because once again, we will have to directly run this thing. Excuse me for a moment. There we go. So I'm going to start by declaring the package main, just as we did before. You know, I'll even actually go ahead and copy paste all of these things, because minus the worker, we're going to need all of them. And I'm quite lazy. So we're going to go ahead and do that. Oops. We don't need the worker because this isn't a worker. Awesome. So now we can start writing our main function. I probably should have copied this as well, because we're going to go ahead and just do all that client instantiation again, but you know, you live and you learn. So create that client. So client.new client. And there's a lot of cool stuff you can do with the options here. We're not going to get into it today, but there's some configurability. You can plug in your own logger, and you know, if you're connecting, like if you're using our cloud, for example, you'll have a different endpoint that you'll need to plug in there. But other than that, you know. Okay, to create client. Nice. All right, so we got the boilerplate stuff. We got to do the defer because we don't want to, you know, dangle pointers essentially. Nice. All right, and so now we're getting into the part where we're actually going to use the starter portion of the logic. So we have to start by defining some workflow options. These are, you know, there's like API reference available online, but essentially this just kind of says to the temporal service, like which workflow are you starting and which task queue is that going to be started on. And so we're going to say, you know, hello workflow video or something. It's not too important here. It has to be something unique. The second thing is task queue. We already defined what the task queue is called in the last file in the worker, and those definitely need to match up. So we're going to make sure that it does, and it does. So now we have our workflow options defined. We're good there. So now it's actually going to get to the point where we need to like execute this workflow. We need to start it. So we're going to go ahead and take a workflow execution and error as a response, and we're going to use the client to do execute workflow. This takes quite a few parameters. One is the background, which I just provided. One is the workflow options, which we just created right before. It takes in the workflow implementation itself. You can also provide like a string name of the workflow, but it's just easier to provide the actual implementation if you have it. And then this is essentially the argument that we're going to pass in to that workflow. And it maps directly to that name parameter, which is a string right here. So if you're curious about why we're putting that at the end, that's why. So we can even say like first video. Awesome. And so immediately we see that it's complaining because we don't have context imported. So let's go ahead and get that out of the way. It should be happy now. So all that we're left to do is actually like, you know, first of all, we need to check if there's an error. Because there could have been an error from starting the workflow execution. Now, to be clear, this wouldn't be an error from the workflow level code failing. This is an error if like the temporal service is unable to even run the workflow in the first place. So we're going to go ahead and do that, or register the workflow in the first place. And so now we're actually at the point where we've executed this workflow. We don't know what the result is, so we want to go ahead and do that, get the result. So we're going to define a variable, which is a string called result. And then we're going to go ahead and call a new method of workflow execution, which is called get, because it returns a future. And so now we're going to plug in the context background, and we're going to provide like a ref to that actual string parameter. And so now whatever was stored as the result of the execution of our workflow is going to be in that result string. And so last thing we need to do is double check the error again. So let's go ahead and do that. Now this is a different one. So this would mean that your workflow has already successfully been sort of acted by the temporal service. It's running, but then maybe the temporal service was down when you actually tried to get the result or something like that. And so now all the logic flow is done. We just want to make sure that we print out like what the result of our workflow was, because that's why we're all doing this. So let's go ahead and do that. Awesome. So this is actually a pretty big milestone, because now at this point we're able to do an end-to-end test of our workflow and see if things are actually working as we expect. So let's go ahead and do that. So the first thing we have to do is we have to run the worker. So we're going to go ahead and run it. Awesome. We're not going to get any feedback there until we try our starter. So let's go ahead and try that. Awesome. So the workflow did run. We can see because there was no errors. The thing is that the result is empty. And so the reason why that's happening is because it is empty. We haven't returned anything. So let's go ahead and return a name first, just to, kind of sanity check ourselves and make sure things are working. And so now we're going to go ahead and just cancel this worker. Whenever you change your workflow code, you do have to restart the worker process. So we're going to go ahead and restart our worker and run our starter. Awesome. So now we can see that the argument that we passed to this execute workflow call in the starter, which is like at the end, the first video parameter, that it was propagated successfully to our workflow execution. It was provided as a parameter, as this name. And then we used that and returned it to the user who executed the workflow in the first place, and we have our end-to-end example. And so now we have something working up and running with Temporal. So congratulations there. But we actually didn't really fully finish our workflow implementation. We kind of skipped over those details when we did it initially. So let's just go back and finish that off, and then we'll be done for today. So as we saw, we're just returning the name right now, but it would be cool if we could actually like see how this would work if we were running with the activity, and we did some sort of processing, some magic there, and then return that back to the user. And so the first thing we need to do if we want to do that is create something called activity options, and this basically just provides some like metadata or configuration is a better way to put it, about how your activity will be executed in the context of this workflow. So the first one is the schedule to start timeout. Not going to cover these too much, but they basically define how long workflows or task queues should wait for a task to be picked up. So we're just going to provide minute because they're good same defaults. Awesome. And so, yeah, it's going to want us to import time. That makes sense. Good call, go. So we have our activity options now. So one of the things to actually apply these, we want to make sure that we do, like we have a call in the workflow, which is called with activity options, and we're going to provide those options that we just defined. Oh, we have to provide the context first, I think. Yeah. Awesome. So now our context is using those activity options. So if we use it in any calls throughout the workflow from now on, it will actually use that context with those options. So now the next thing we need to do is we want to make sure we have like a logger so we know what's going on. So let's do workflow.getLogger, and we have to provide the context. Nice. And so now we actually are in the place where we can execute this activity. So to do that, let's go down here and let's basically, we need to get a result, which is a string. Because that's what our activity is going to return, we said right here. So the next thing we need to do is actually execute the activity. So let's go and do that, workflow.execute activity. It's going to take that context that we just worked with. It's going to take the actual activity implementation, so that's down there. We call that activity, and it's going to take in a parameter, which is the name that we got as the parameter to the workflow itself. Now it returns a future, so we're going to go ahead and provide the context and the reference to the results, so that way it can store it in that variable once it finishes. And so we do need to check to see if there's an error. Again, the activity could fail to even be sent to the service itself, and so you want to know, because then you need to resend it. Now, luckily, Temporal provides built-in retries and timeouts for activities, so even if the activity were to fail in the default case, it would be retried automatically, so that wouldn't even be something you have to deal with. And so that runs the activity. We're basically done. The last thing we have to do is just basically replace this name parameter that we were returning directly with the result of the activity. Awesome. So our workflow implementation is completely done. The last thing that we have to do is basically, like do something with the activity. Now, there isn't really a lot of complexity here. In fact, I don't think really we want to do anything other than just return hello plus whatever the thing that the user provided was. So let's just do hello plus name. And awesome. We are officially done with our first activity in workflow. Go ahead and restart the worker because that's required. And wait for that to be up and run our starter. And what we should see is hello first video. And now we can kind of play with this if we would like and really, validate that it's working the way that we think it is. We'll go to the end and we'll just change this to be like tutorial or audience. A lot of internal confusion there. Wasn't sure what I wanted to call it. All right, and if everything I've led you to believe is true so far, then this will return hello audience, and indeed it does. So we've now officially completed the end-to-end for this tutorial. We have a workflow, we have an activity that it calls and returns something back to the user. We have a worker which can actually host that workflow code and make it available for when we send a workflow start request. And on that same note, we have a workflow starter which is able to actually send a signal to the temporal service that this workflow execution needs to start, and eventually then get that response back to the user with this workflow get call. And so that's the end to end of this example. I think it's a great start because it gives you a very high level understanding of how Temporal works and how to write a simple workflow. And so in the next tutorial, we'll start getting a little bit more advanced and see what we can do, so maybe with some things like signals and queries. So thank you all.